Properties of limits. Okay, if L, M, C, and K are real numbers, and the limit of f of x as x approaches c equals L, and the limit of g of x as x approaches c equals M, then, well, this is all really complicated. Let me simplify it. So if you have the limit of two functions either added together or subtracted, then you basically split it. So you take the limit of f of x and the limit of g of x, and then you add them or subtract them depending on the sign here. Now if you have the limit of two functions multiplied together, then you take the limit of the first and you multiply it by the limit of the second. If you have the limit of two functions in a fraction like this, are divided by each other, then you split the limit. You have the limit of this first function f of x, and then you divide it by the limit of g of x. If you have the limit of a function multiplied by, this is an integer here, or any real number, then you take the number and you move it outside the limit. So now you just have the limit, you have k times the limit of f of x as x approaches c. If you have the limit of a function raised to an exponent, then you take the exponent and you move it outside the limit. So now you have this L is k, it's basically this. You take the limit and then you raise that limit to the exponent. Now if you have a limit of a composite function like this, then what you do is you take the f or g or whatever it is, and you move it to the outside of the limit. So now you have f of the limit of g of x as x approaches c. We'll see some examples. So first, let me show you how to determine limits using just the equation, not like graphs or tables like we used in the last lesson, just an equation. So if you have, let's say, the limit of 3x squared minus 5x plus 1 as x approaches 2, what would you do in this situation? Well, if you have a function like this, the best thing to do is to plug in the x value right away. So that would just equal 3 times 2 squared minus 5 times 2 plus 1. You substitute the x for 2 here, and that's 12 plus 10 plus 1. That's a minus. 12 minus 10 plus 1 with 3. That's how you find the limit of just normal equation. Now let's try out the properties. So you have the limit of cosine of pi over x minus the sine of pi x over 6. First thing to do would be to split up this function into two limits. Limit, here's 3 is pi over x minus the limit of sine pi 6 over x. So whenever there you have a plus, minus, times, divided by, what you do is you split the limits across the two functions. Now we have these, the limit of cosine pi over x and the limit of sine pi x over 6. Now here there's nothing really left to do other than substituting x for 3. Plug in 3, so you have cosine pi over 3 minus sine of 3 pi over 6. 3 pi over 6 is the same as pi over 2. It's easy that way. And if you remember from the unit circle, the cosine of pi over 3 is 1/2. And the sine of pi over 2 is 1. And 1/2 minus 1 equals negative 1/2. The answer to this. Let's do another one here. Here in this situation, you have e to the L to the nat log of x plus 5. You may remember from pre-cal when you have e to the power of a natural logarithm, they cancel each other out. And you're just left with this x plus 5 right here. So you'd have limit equals negative 1 of x plus 5. That's it. It's really simple. Now you plug in negative 1 for x. You get 4 for this one. Alright. So now we have two functions here. F of x is x minus 5. And g of x is x squared. So if you remember from the properties we just talked about, you have an exponent here. What you do is you take the exponent and you move it completely outside everything. So what I mean by that is you have limit of x over 1 f of x. And now that the exponent is outside everything, you basically take this limit and you put it in here. So now you take the limit of f of x as x approaches 1. That would be, since f of x is x minus 5, you have 1 minus 5 squared. There's negative 4 squared. That's 16. You have another one. So for the composite functions, as you see right here, we do take the f or the g, whatever, in this case it's a g, and you place on the outside. So now you have g of the limit of x approaching negative 1, 1/2 f of x. See, now this isn't done just yet. Now you take this 1/2 and you put it outside the limit. So you have g of 1/2 times the limit is x approaches negative 1 of f of x. The limit of f of x is x approaches 1, so you substitute in the function for that. X minus 5, so it'll be negative 1 minus 5. Negative 1 minus 5 is negative 6. Half of that is negative 3. So now you have g of negative 3, and since g of x is x squared, that would be negative 3 squared, because you plug in the negative 3 for x. Negative 3 squared is 9. And that's the answer to this limit. Alright, we have another one. This is a more complicated composite function, but it still works the same way. You take your f here, you put it on the outside. Now you do the same thing again with the second f here. Now you take this 2 right here, you put it outside the limit. And the limit of g of x as x approaches 2. Here you just plug in negative 2 for x here. Negative 2 squared. That would be 2 times 4, which is 8. Now f of 8 here, you have 8 minus 5, because you plug in 8 for x here. Now you have f of 3. Now you plug in 3 for x again. 3 minus 5, negative 2. now we have these pictures. The first one here is f of x, and the second one here is g of x. So for the first one, since we're adding the two functions together, what you do is you take the limit and of these two functions and you just add them together. So this would be the x approaches 2 of f of x plus the limit as x approaches 2 of g of x. And you evaluate these independently. So now we have f of x as it approaches 2. So 2 is right here. As we approach 2 right here, we have the value right here, it's 2. You get the same thing for g of x. 2 is right here. That'd be right here at 0. Just 2. Now same thing for this next one. You take it, the limit, and you split it apart. You minus, because there's a minus here. Now what we do here is you take the 2, and you move it outside the limit. So now we have limit, here's 1. And now you can evaluate these limits here. So the limit of f of x as x approaches 1 on the left, it would be, let me erase this first. It would be, as you can see right here, it's 1. And minus 2 times limit of g of x as x approaches 1 from the left. Remember this minus right here, and the limit means from the left. So you're approaching from the left, and right here it's at 2, y equals 2 right here. That would be 1 minus 4. So the answer is negative 3. Here's the last one here. You take the limits and you split them apart again. This time, you're multiplying the limits. We're done here. We don't need to simplify it any further. Now you evaluate these limits. So f of x as x approaches 1, that's 1. G of x as x approaches 1 from the left, that's 2. So the answer to that is 2. Let's do some more with these exact same graphs from earlier. Now we have composite functions. So now this limit of g of f of x as x approaches negative 1. As we did before, you take the g, you move it outside. And now you can evaluate this limit. So limit of f of x as x approaches negative 1. That's right here. That's at negative 1. That would be g of negative 1. Now g of negative 1, you plug negative 1 here, you get 0. Now this one might seem a little bit tricky, but it's the same as the other multiplication ones. What you do is you take the limit and you distribute it across both of these. So you have the limit as x approaches 2 of x times limit as x approaches 2 of f of x. Now let's talk about this really quickly here. This is just like those other plug-in functions that we encountered before. All you have to do is just plug in 2 here, because all there is an x. So that should be 2 Now this here, the limit of fx as x approaches 2. 2 is right here. That it approaches 2. If 2 times 2, which is 4. Now this one here, keep in mind the square root is just an exponent, but to the 1/2 is just, square root is just 1/2, remember that. So we can apply the same rules to it. We can cover the entire limit with the square root. Now what you do in this situation is you distribute the limit across both of these. So you get the limit as x approaches 2 from the right, or negative 2 from the right, of 7 plus the limit as x approaches negative 2 from the right of g of x. And again here, you have a constant. This 7 here is just a straight line, really. This is at y equals 7, right? What this means is you're supposed to plug in negative 2 for x right here, but there's no x. The limit of any constant is just that constant. In other words, we can just ignore this entirely. So now we have just 7 plus the limit of g of x as x approaches negative 2 from the right. Now we can evaluate this, g of x. We have negative 2 right here from the right, and that's at negative 2. With the square root of 7 plus negative 2, which is the square root of 5. Right over here you have this normal x squared function and this piecewise function. What we do here, so first we're going to distribute these limits. And multiply them, because these functions are being multiplied. And now we can evaluate these. So first you can just plug in negative 2 into x squared here to get negative 2 squared. Now if you plug in negative 2 to g of x here, since negative 2 is less than 0, we'd use this expression here. So you get negative 2 plus 1. Negative 2 squared is 4. Negative 2 plus 1 is negative 1. And 4 times negative 1 is negative 4. Let's do another one with the same functions from earlier. Now you have this composite function. As long as you take the g to get outside of the limit. You have the limit of f of x as x approaches 2. In that case, you just plug in 2 for x here. You get g of 4. Now you plug in 4 for x in g of x. This 4 is greater than 0. You'd use this one. So you have negative 4 minus 2. G equal negative 6. Alright, last one. Another composite function here. First you take the 3, you move it outside of the limit. Now you take the g, and you move it outside. Now you can evaluate this. Here's the thing with this limit. This is a piecewise function and it changes at 0, and you're trying to find the limit as x approaches 0. So what would you do in this situation? So what you do is you'd evaluate it coming from the left and coming from the right. So you'd have the limit as x approaches, let's do it from the left first. Just from the left, right? Because coming from the left, that means it's less than 0. It's coming from the side that's less than 0. So you'd use this expression, x plus 1, right here. So that means 0 plus 1 would come out to 1. Now, let's do it from the right. So we do it from the right, so that means we're dealing with values that are greater than 0, and we're approaching 0. Now we use this bottom expression here, negative x minus 2. So that would be negative 0 minus 2. It just turned out to be negative 2. Notice that 1 here and negative 2 aren't equal, as we covered in the first lesson. So we have different behavior on the left and the right. That means that the limit does not exist. So you'd have to write if x approaches 0 of g of x does not exist. So here you'd have 3g does not exist, which means the entire thing comes out to dne, does not exist.